Hello, welcome to the final heat transfer video. This video will look at radiation. So again, you'll just need to be able to explain how heat transfer can occur through conduction, convection, specifically in this video, radiation, and you'll need to be able to describe examples of this heat transfer process. So radiation is heat transfer that occurs through emission and absorption of electromagnetic radiation. This electromagnetic radiation is emitted by materials or objects with a temperature above 0 Kelvin, so anything that has a temperature that is above absolute zero. And this emission is due to thermal motion, so vibration of particles. Electromagnetic radiation that hits an object is partially reflected, it's partially transmitted, and it's also partially absorbed. And it's this absorbed part that transfers thermal energy to an object, and that results in an increase in temperature for that object. This is the only form of heat transfer that doesn't require direct contact. So as an example of a description of how to explain this type of heat transfer, you might be asked to explain the heat transfer by thermal radiation between a heater and a person's hands. So what's happening here is before the heat is even transferred, electrical energy is transferred to the metal element of the heater. This increases the vibrational kinetic energy of the metal atoms within the element. The vibrating atoms emit electromagnetic radiation, and this radiation propagates away from the heater. It's then absorbed by the hands, and this results in an increase in the hand temperature. Another example of radiation or thermal radiation that you might have to explain is the heat transfer between the Earth and greenhouse gases in the atmosphere, so carbon dioxide and methane. So what's happening here is that thermal energy from particles on the Earth, so this could be the surface of the Earth, it could be water on the Earth, it could also be from other areas within the atmosphere. This thermal energy is transferred to greenhouse gas molecules via radiation. The various particles on Earth have vibrational kinetic energy, and this is what emits this electromagnetic radiation. So this is what is being radiated here. Greenhouse gases then absorb this radiation, or this electromagnetic radiation, and then their own vibrational kinetic energy increases, and they then re-radiate thermal energy back to the Earth's surface. In normal times, this re-radiation of thermal energy back to the surface of the Earth maintained the Earth's temperature at a level that can support life on Earth. However, currently, because there's an increase in greenhouse gas concentration in the atmosphere, there's a much greater level of absorption of thermal radiation, and therefore a much greater level of re-radiation back to the Earth of this thermal energy, and as a result the average global temperature is increasing, and this is the mechanism of climate change. And just to note, the original thermal energy on the Earth, so that is the thermal energy that is causing the particles that make up everything on the Earth to vibrate, this is transferred via radiation from the sun. Emissivity refers to the ability of an object to emit thermal radiation that has been absorbed, and it is represented by this little epsilon E here. It ranges from 0 through to 1, and it doesn't have any units. Objects with emissivities closer to zero are poor emitters. This means that they retain most of their absorbed thermal energy. So an example of these is metals. So they absorb most of their thermal energy, they don't emit or radiate it. So this is why metals can be really hot to touch if they've been in the sun, because they've absorbed most of that thermal energy. Objects or materials with emissivities closer to 1 are excellent emitters. This means that they emit most of their thermal energy absorbed. So examples of these are wood and human skin. So they radiate and emit the energy that they absorb and get rid of it. So an example that considers this is if you've got, for example, 80-degree water, some of it's in a shiny can and an equal amount is in a dull black can. We wanted to work out which water decreases in temperature faster, so which has a faster rate of temperature decrease. The bright shiny can is going to have a much lower emissivity, whereas the dull black can's emissivity is going to be higher. So the metal, or the shiny metal can, will be a poorer emitter and it will retain most of the thermal energy that it absorbs, whereas the dull black can will be a better emitter and will emit or radiate most of the energy thermal energy that it absorbs. So because the can has the higher emissivity, heat is transferred from the black can by thermal radiation at a greater rate, and this means that there's a much more rapid decrease in the temperature of the water in the black can because the black can itself is getting rid of its thermal radiation, whereas as in the thermal radiation that's coming from electromagnetic radiation, whereas the bright shiny can absorbs electromagnetic radiation, and this means that it can maintain the water at a warmer temperature for longer. So the temperature decrease rate is less.